Let me consider a liquid in a container and observe the two molecules, one on the top of the surface and one which is well inside the liquid. This liquid molecule is surrounded by other liquid molecules from all sides, and due to these attractive forces of all other molecules, the potential energy will be negative. We know attractive forces means negative potential energy. For the molecule which is on the top surface, from half side it is surrounded by the molecules of the air, but on the other half it is surrounded by the liquid molecules. So potential energy of this is also negative, but because of less pairs of the molecules, it is negative, but UA is less negative. Less negative means UA is more than UB. So liquid molecules which are on the surface of the liquid have more potential energy than the molecules which are well inside the liquid. And we know that every configuration, every system has a tendency to minimize its energy. It means free surface of a liquid will always tend to minimize its area, so that there are very less number of molecules on the surface and its potential energy is less. Now, if we see in terms of small liquid drops, so due to this tendency of minimize the area, there are forces acting tangentially on the surface, which we call as surface tension forces. So if I consider a liquid drop, then there are surface tension forces acting tangentially trying to reduce the area. And for given volume, a sphere has minimum area. That's why small liquid drops will take a spherical shape. However, if the drops are bigger, then it is not just the surface energy. The potential energy, gravitational potential energy also plays a role, and the drop tries to minimize even the gravitational potential energy. So the shape is no longer perfectly spherical in an attempt to lower the center of gravity. But small drops where we can ignore the weight, surface tension forces are acting, and due to these forces, the shape of the liquid drop becomes spherical.